Look, shock today, alright? We're going to look at shock. There's 4 types. Jump in with the first one, hypovolemic, alright? Hypovolemic is the most easiest one. You can just think of diarrhea, hemorrhage, burns, alright? Maybe even diaphoresis if you want, but let's just stick with these 3. Diarrhea, you're going to lose a lot of volume of water. Hemorrhage, you're going to lose internal and external hemorrhage. And burns, of course, loss of proteins means less oncotic pressure, which means edema. Now, cardiogenic. Cardiogenic is all about the heart, right? Not any external factors, just the heart. We can split this up into 3 types. Early obstructive and filling defect. Okay, now with obstructive, okay, this has been argued to be a separate category. However, we can still include it in this category. When I say it could be another category, I mean like this, obstructive. But within cardiogenic, we can include it. I'll tell you why. So firstly, let's talk about emptying abnormality, emptying deficit. And here we have myocardial infarction. If you have myocardial infarction, you're going to have a cellular destruction in the, let's say, ventricles. And if you have cells, myocardial cells in the ventricle that are ineffective, if they are dead, they won't be able to contract, and therefore less cardiac output is being ejected. Arrhythmia. So here we have basically less ventricular filling, less time filling, which means less cardiac output in general. Obstructive. Now, when I say obstructive, I mean, so within the heart, the main thing you can focus on here is stenosis. So aortic stenosis here is blocking the obstruction, it's blocking the ejection of the heart. And filling defect, very simply, cardiac tamponade, the external pressure from the pericardium squeezing the heart, and that is causing a reduction in the filling capacity of the heart. Let's go to obstructive now. And obstructive, this is now due to extracardial problems, not intracardial, which is cardiogenic, but extracardial things outside the heart. So factors here could include tension pneumothorax. So with tension pneumothorax, air should not be within the pleural cavity. Okay. Physiologically, we have a negative pressure. However, if you have air going in, this is going to cause a buildup of pressure, and if you know your radiology, this is going to cause a mediastinal shift, as you can see. If you look at the border of the heart, the red border is physiological. However, the gray border, as you can see, there's a caving in within the heart due to the increase in mediastinal shift, increase in pressure, increase in the intramediastinal pressure. It's going to shift the outline, the border of the heart. It's going to cave it in, and what's that going to cause? A reduction in the ejection capability, right? Because look, there's no room for it to eject the blood out of the heart. Next, pulmonary embolism. Pretty simple, there's an obstruction there. These things, you could think of it as an increase in afterload, maybe. But yeah, that's that. And finally, distributive. This is more of your bit complicated, but it shouldn't be really. So I split it up into 4 types. And anaphylactic and septic, you can categorize these into similar traits. So these 2 are kind of similar. Okay, anaphylactic and septic, they're kind of the same mechanism that's going on. All right, so with anaphylactic, obviously there's some allergic type 1 hypersensitivity response going on, And what's going to happen? There's going to be vasodilation, and with vasodilation there's going to be edema due to the increased capillary permeability. And with a increase in vessel diameter, you're going to have a reduction in blood pressure. If you have a reduction in blood pressure, you're going to have a decrease in the venous return to the heart. And septic follows the same kind of trajectory, meaning that there is going to be systemic inflammation, and with systemic inflammation, you're going to have increase in the vasodilation and therefore decreased blood pressure. Therefore, a decrease in venous return, and especially this question was on the colloquium as well. So yeah, and these two, endocrine and neurogenic, they are separate. So yeah, you can't really group them together. Endocrine, now with endocrine, there's many different glands that can cause some sort of impact on the cardiac output, such as thyroid hormone increased or decreased function. However, I'm not going to go into that because it's this is more easier to think of. But yeah, let's just put it to the side, I guess, just for you to keep in your mind that thyroid hormone can play a part. Okay, but let's focus on Addison's. Now with Addison's, we know that there is a decrease in the ADH function, decreased aldosterone, and what this means is there's going to be more sodium excretion, and with sodium excretion there's going to be increased volume of water that follows, and so you're going to have a decrease in systemic intravascular volume as a whole. And finally, neurogenic or spinal. Now with this type of shock, what's going on here is to do with your sympathetic nervous system. Now imagine the spinal cord here, and of course in certain aspects, certain areas of the spinal cord, you have your sympathetic nerves innervating certain organs such as your heart. So I'll put T6 here as being an example towards the heart. If this is damaged, you're going to damage the sympathetic nervous system and its innervation to the heart. Now, damaging this, what's going to cause? Bradycardia, hypertension. Alright, that's just going to decrease blood pressure and therefore decrease cardiac output and therefore causing shock. Brilliant. Alright, there you have it. 4 different types of shock. Pretty simple. And yeah, hope it makes sense.